Hi, my name is Uksandavne, and this is my Week 4, Chapter 12, Video 5, Question 37 to 39 video assignment. Question 37 gives us the piecewise function and tells us to identify what the limits are approaching from the right, the limit as x approaches 0 from the left, and the limit as x approaches 0 from both sides. In order to first begin on this question, we need to understand how limits function, and we need to understand how limit notation first works. Let's first talk about limit notation. First, there's three different types of limit notation that we can understand. First is the general limit notation. Limit as x approaches a from both the right and the left, f of x equals c. Our input value is a. A is going to be our x-axis, and f of x is the function, which then provides us with an output value, which will be our c value. Again, remember that this is limit as it approaches from both sides. That is also known as the general limit. General limit. Second, we have limit as x approaches a from the right, f of x equals c. The positive sign indicates that the limit is approaching from the right, is coming this way, approaching from the right, and this is known as the right hand limit. Lastly, we have limit as x approaches a from the left, f of x equals c. This is the left-hand limit because the negative sign indicates that limit as x approaches a from the left, indicating coming from the left side, f of x is equal to c. Again, our input value, output value, and our function. Now that we understand how limit notation works, let's talk a little bit about how we can approach this problem. First, let's talk about what we have to actually identify in this problem. The problem gives us a piecewise function of 2x squared plus 2x plus 1, where x has to meet the criteria of being less than or equal to 0. And our second equation is x minus 3, and x has to be greater than 0. Well, in order to first start on this problem, let's ask what it's asking. Let's find out what it's asking. Limit as x approaches 0, the positive symbol from the right. So limit as it approaches from the right. Well, we can see that the right conceptually indicates that it has to be greater than 0. Means that's why it's coming from the right. Therefore, we identify which of these equations meets that criteria. Well, it would be the x minus 3 because it says x is greater than 0, so it's coming from the right. Now, how we set up our limit notation, we have to keep in mind that we set up limit notation every single time. Limit as x approaches 0, f of x is equal to x minus 3. Then we are going to use direct substitution, where we have to rewrite it. Limit as x approaches 0 from the right, f of, well, what are we plugging in? We're just plugging in a 0. F of 0 is equal to 0 minus 3. We can then write that as equal to limit x approaches 0 from the right, f of 0. Well, 0 minus 3 is just negative 3. So we've identified our right-hand limit. That is right-hand limit is equal to negative 3. Next, the question then continues and asks us in a very similar way to simply identify the left-hand limit. It says limit as x approaches 0 from the left, f of x equals what? Well, they're telling us again to identify our output value when they've given us our input value of 0. We also have to identify which of these equations meets that criteria. If something is coming from the left, what is it? Well, it's going to be less than 0. So we need an equation that meets that criteria. Well, this one is x is greater than 0, so that doesn't meet it. But the top equation says x is less than or equal to 0. So yes, it does meet that criteria, meaning that we're going to use, again, rewriting with our limit notation, limit as x approaches 0 from, again, the left, f of x equals 2x squared plus 2x plus 1. Again, directly taking this equation up here, plugging it in down there. We then use direct substitution, where we find limit as x approaches 0 from the left, f of, well, we're plugging in 0. That's what we're plugging in, f of 0, which is where we're plugging in. And then 2, we can plug in the 0. Go ahead, plug in the 0. 2 times 0 squared plus 2 times 0 plus 1. Well, 0 squared is still 0. 2 times that 0 is going to continue to be 0. So 0 plus 2 times 0 is 0, plus 1 is equal to 1. So rewriting our limit notation here, we can say limit as x approaches 0 from the left, f of x is equal to 1. So this is equal to our left-hand limit. We've identified our right-hand limit, which is -3, and our left-hand limit, which is 1. The only step that remains is to identify our general limit. A general limit is a limit where it's asking to what does it approach from both sides. So we know what it approaches from the right and we know what it approaches from the left. It's asking us, what does it approach from both sides? Well, in order to answer this question, we don't actually have a general limit. The reason being is because the right-hand limit is not equal to the left-hand limit. When this happens, it could possibly be a jump discontinuity. For example, as you can see, our right-hand limit, let me write that, hand limit is equal to 1, whereas our left-hand limit is equal to -3. These two are not equal, proving that there is no general limit. Another notation, how you can notate this properly, is limit as x approaches 0 from the left is not equal to limit as x approaches 0 from the right. This entails that there is no general limit. An example of, just a graphical example of when such an incident could occur is with a jump discontinuity. For example, let's just say our equation is looking something like this. It goes down this way and it comes up this way. But we can see that there's a gap. So as it approaches from the left and it approaches from the right, they don't meet at a single point. There is a discontinuity that is present in between the 2 points. That is why there is no general limit. Again, remember, for a limit to be continuous, as shown in this example, we can take, for example, a line that looks like this. Let's just say that the limit is here. As it approaches from the left, it goes to this point, and as it approaches from the right, it goes to this exact same point. So that is not the case in this situation because the right-hand limit is not equal to the left-hand limit, which proves that our problem does not have a general limit. We found all our limits, and we've also understand how limit notation works. Thank you for watching.